Colorado. I work in consulting right now at Denny Cherry and Associates Consulting. I've been there about 4 years, but I've been consulting since 2012. So been doing this for quite a while now. I'm a Microsoft Data Platform MVP. I talk a lot about Azure Data Factory as well as Power BI and some SQL stuff as well. I blog a lot. I speak, obviously. I'm also an author. We just had a book come out for SQL Server Inside Out, Administering SQL Server 2022, which is now available. So if you like books, please buy it so I can get my 1 penny in royalties. And I do some technical editing as well. So I wrote this presentation because some things are hard to change after the fact in Data Factory, and there are mistakes that I made previously that I see a lot of my clients make, or people that have questions and forums online, and I want to help. I want to help you avoid that. And if you haven't looked at Azure Data Factory in a while, maybe a couple years, there are some changes that you should be aware of, and you may want to revisit this topic. So even if you know a little Azure Data Factory, this might be a good refresher. And if you don't, I'm going to talk less about the intricacies of building pipelines and more about how do we set ourselves up for success. So if you don't know the very basics of Azure Data Factory, this might be a little fast for you, but it's something you can come back to later once you get started. So here are the top regrets that I have seen over the last several years. So I've been using Data Factory since before V2 was available and have been a consultant that entire time. And here's what I noticed. Poor resource organization in Azure, how you group your data factories and name them, lack of naming conventions both at the Azure resource level and within the data factory itself, how you name pipelines and data sets, that sort of thing. Inconsistent or lack of key vault usage. Lack of or inappropriate use of version control. Lately, most people I've seen are using version control, not always, but most, but they're doing it in a way that really doesn't benefit them and isn't the recommended way. I see lots of tedious manual deployments, a lot of misunderstanding of integration runtimes, and we'll talk about what those are and when we use each one. Not using enough parameterization in pipelines and link services and data sets, causing a lot of bloat within the data factory of all the objects in there. And not having established pipeline design patterns. Before I did Data Factory, I did SSIS, and I had basically the same kind of rant on that side of, if you can think about it in design patterns, it's going to go a lot better and be a lot more maintainable and easier for other people to learn. And of course, the perpetual lack of documentation or comments. So we're going to take a quick survey of all these things over the next hour so that maybe a couple of these things will stick in your head the next time you build a data factory. First, let's talk resource organization. You need separate data factories and key vaults for each environment. So if you have dev, test, and prod, you're going to have dev, test, and prod data factories. Same thing for key vaults. There are different ways for separating those environments, and it really depends on your needs as to which one is best. There is no one single way to do this. The first way is just have separate resource groups. Maybe you have a single subscription, but dev is a resource group, test is a resource group, and prod is a resource group. And that's fine. You could also separate by subscriptions and have entirely separate subscriptions for dev, test, and prod. Some people go way out there, and this is the least common, and do separate tenants. That's usually not what you'll do kind of internally for your resources, but if you were, let's say, an ISV where you create a solution that includes Data Factory that you then offer like as a multi-tenant type thing for customers, that's where you'll see the tenant separation most of the time. So when I say separate resource groups, it might look something like this. You have a single AD tenant and a single subscription with, I'm going to assume you have 3 environments in here. You might have 2, you might have 4. You probably want more than one. This will still be attached to a single DevOps project and a single repo. The alternative is we still probably have a resource group that contains your data factory. The key vault may or may not be in the same resource group. It's less important now. But you'll have a dev, test, and prod subscription, but still all connected to the same DevOps project. And there's only one repo for the data factory. When we talk about naming conventions, I said this earlier, but there's 2 levels we have to consider. There's the Azure resource level, like what you see in the Azure portal. And then there's the Data Factory artifacts level. So what do you see in ADF Studio? And there are 2 different schools of thought about resource naming. One is that the name doesn't matter because we have tags. And the other is that the name should have some kind of convention. And I say tags plus names is probably the answer. I really do not care what you name them. I just want you to name your resources consistently. That is the most important thing. So if you need suggestions, if you look in Microsoft Learn, there's an Azure Cloud Adoption Framework, and it has guidance similar to what I'm going to show you here. I feel like it's pretty formal and it offers some longer options for large enterprises, but you can, pick and choose what you like out of it. So I'm going to show you an example of naming conventions. I may have a data factory and I may want to follow this naming convention, which is pretty much like the cloud adoption framework: resource type, workload, or application environment. So it might be ADF, I don't know, data warehouse load, dev. You can get more information in the name. So you could add the Azure region or an instance name or number ID, something like that. It's whatever works best for you. So there are arguments online about names versus tags, and I will say, yes, you should absolutely use tags. And you can use tags to distinguish types and environments. The issue is, will others? When people interact with that resource, will they remember to go look at the tags? Will they remember to add tags to be consistent? So I call it naming defensively, because I don't know who's going to interact with my data factory or related resources via the portal manually or via code. If you're interacting with the data factory via code, you have to make a separate call to get the tags. And that's why I say I name consistently and defensively. You don't want a bunch of ADF 123, ADF 1234 out there, because you'll never remember which one does what. We also need to make our resource names unique. I have a blog about this if you're ever curious. But when you create a resource in Azure, you get a managed identity with it. So the actual resource has its own service principal. And the name of the managed identity is the name of the resource. There are restrictions in Azure about how you name things, but most of the naming restrictions are not global. They're within the type of the resource. So I can actually have a data factory and a SQL server, and a database within that SQL server all have the same name. And I may have turned on managed identities for SQL Server. You automatically get one with Data Factory. And so when I'm using those managed identities to grant access, when I search for it, it's going to look exactly the same. When I write code for it, I have to know the actual ID. So if someone is not careful and they're just, going along, granting access or moving something to another resource, and they do it based on the name and they don't notice the type, this can cause issues. So I just make sure my resource names are unique across types, which is why the type is often part of my naming convention. So that was the actual Azure resource, but within Data Factory, we have a few different kinds of artifacts. We have pipelines, we have data sets, we have link services, we have integration runtimes. There are several things that we need to name. And they're usually set in separate sections. There's a pipeline section in ADF Studio, which we'll see in a second. But when we interact with Data Factory using code, we don't see that like we do in the UI. So it's often helpful just to start the artifact type with PL for pipeline, DS for dataset, LS for linked service. We also want to say what they do. What does this pipeline do? Does it copy something? Does it transform something? Does it execute an SSIS package? Give us some indication so that when I have a data factory with 50 to 100 pipelines, I can find the one I'm looking for really easily because it's a pipeline, it copies, and it'll usually say something about what it's copying or where it's copying to. Data sets and linked services should have the same kind of naming conventions. So they should indicate the type of data and the subject of data, and you'll see an example screenshot in a second. So here's a screenshot from my data factory. I have PL execute copies. It is a high-level pipeline that executes other pipelines that do perform copy activities, basically. They're copying things from blob storage to a database. PL copy blob, I'm copying files from blob storage. I have an orchestrator pipeline, and we'll talk about what these mean a little later, but again, PL, orchestrator, incremental, so I'm copying something incrementally. My data set starts with DS. ABLB is Azure Blob Storage, and I'm copying CSVs because the data set is tied to the file format. This is the type of thing that, yeah, this is really simple. It's got, 3 pipelines in it, but imagine when this gets to 20, 50, 70, it becomes very, very helpful. And again, if you're not using the UI because you've automated some things, it's way more helpful there. I'm gonna switch how I have things set up real quick. There we go. Okay. Key vault. Key vault is a really important part of setting up your data factory, and a lot of people miss it. They don't learn about it before they start going. If you don't work a lot in Azure, a key vault can store secrets, and the secret can be anything. It can be a username, a password, a connection string, and it can be a centralized asset in your Azure subscription. It's built to securely hold your secrets. So there's no extra code you have to write to keep things secure. You can actually hook it up to your data factory via what's called a linked service, or you can actually just reference it in a web activity to retrieve a credential. This also, you don't know it until you've tried to publish something, but when we publish link services, which are kind of like connection strings, If we do not use a key vault, they will be immediately published. It doesn't matter if you're in a feature branch developing off on your own, it gets published to the service right away. This is the only thing that does this. But if you use the key vault, this doesn't happen. And it's because when you enter credentials into Data Factory, you get your credentials get stored in an encrypted data store inside the Data Factory service. So in order to encrypt and store it, it has to go to the service immediately. But if you're storing your credentials in Azure Key Vault, then it doesn't have that issue. And your code, this new link service or updated link service you have, stays with your branch and goes through the normal DevOps processes. So I'm going to show you, I'm going to flip to my Data Factory here. And I'm going to go to a linked service. So I have a few different ones. Here's an example of everything looks nice except the one where you just took the generic name. If you have a bunch of data lakes, this is not going to work very well. At least these, I know these are a link service for a SQL database, and the name of the database is DataMart or DemoDB. So I'm going to look at DataMart, where I used an Azure Key Vault link service. So when I'm saying I want to connect to the SQL database, I give it my URL, my domain name rather, my database name. And then in this case, I just chose the authentication type of SQL auth for this. And when I'm entering the link service, I can say for my password, I could type it in like regular, or I can use an Azure Key Vault. So I say, here's the Key Vault where my password is stored. Here's the name of the secret that contains my password. And that's all done. That means that I had to go and enter my password into the Key Vault first. So I could do that, or I can actually put the entire connection string into my Key Vault. So up here, there's another option for Key Vault, and I can say, okay, here's my Key Vault, my secret name. I have an entire connection string in here, and then I can do it that way with the same SQL auth user. So that is just the normal SQL connection string most of us are probably used to seeing. I just stored it over there with my username and password. To make that happen, I had to have an Azure Key Vault linked service set up first. So I just point it to my Key Vault. It connects through a managed identity. That's that managed identity that Azure created when I created the Data Factory. So I had to go to Key Vault and grant access to my Data Factory to be able to read the secrets. But once that's set up, you can store all your secrets there or in as many Key Vaults as you need. One is usually pretty good. And then you don't store sensitive information in your actual linked services.
Megan, real quick. I mean, when we have questions, do you want us to just ask it, or do you want to wait?
Yeah, go ahead and ask.
So I wanted to know, where did you grant access to the Data Factory to the Key Vault?
It's actually on the Key Vault side. When you're in the Key Vault, it's just in the access control. Well, it's actually, it depends on how you set it up. This one, I have access policies.
So that's what I'm trying to figure out.
So there used to not be a role for Key Vaults. You had to go and create access policies. But now there are actual roles like Key Vault leader. But this is my Data Factory right here. this is my managed identity. So it's an application, and I granted it get, list, and set. It's actually got a bunch of stuff. I was doing some testing with it, but yeah. So I did it via the access policies on my Key Vault, but you could also do it through access control.
Okay. And if you do it through the policies, does it give you the name of the managed identity? Because sometimes I think I saw multiple of the PDF, I guess. I don't know. When I was kind of looking through that.
You won't have multiple. You can always see the name of your managed identity. If you go look at your linked services, especially if you create a Key Vault one, it will give you the name.
All right, cool. Thank you.
Yep.
I do want to point out one more thing. I know a third way there's also another way using private endpoints. If you're not opening access to everybody, just have private endpoint available as well. So that way when it reads only within your VNet or whatever, however you configure your private endpoint.
Yep, that doesn't affect how we connect here or what users we use it with. So yes, you can absolutely use a private endpoint to connect to an Azure SQL database, but it doesn't change how we use Key Vault or how we grant access to a Key Vault.
Just to say that, for the restriction of access, so people, it's because, in Key Vault, you're storing secrets, so people are not afraid of using
the user logging into the SQL system.
Right.
Yep, private endpoints are just a networking thing though, so treat them as network security, not anything else.
Thank you, Megan. Thank you.
Yep. So I talked about branching earlier when we talked about the Key Vault usage and linked services. So let's talk about version control. You need version control. Please do not develop without it. You can integrate
Megan? I think you muted yourself, maybe.
Oh, there we go. Teams got stuck. Sorry about that. Let's try that again. You can integrate your ADF project with Azure repos or GitHub. And you just want, despite having multiple environments, you just want one project and one repo. Higher environments like test and prod, they don't get directly tied to a repo because of the recommended deployment process. And I'll go through that. So you should have done everything in your dev ADF, and your code would already be version controlled. And trying to version control dev, test, and prod adds a lot of complexity with basically no benefits. And I have a whole blog post about this on datasavvy.me if you ever get asked this question. And the docs will say that you cannot connect multiple factories to the same repo. I haven't tested it in a long time, so I think they've closed that loophole, but it's definitely not recommended. So, one more extra thing. Last year, towards the end, they released a couple new things about connection to DevOps. You can now disable publishing from ADF Studio in favor of automated publishing, or you can use custom comments when you publish. So let's go back to my data factory. And we're going to go look at my Git configuration. Make this a little bigger. So I'm connected to Azure DevOps. My project name is ADF Deploy Demo. My repo, same name. I have a collaboration branch of main, meaning this is where all of my feature branches get merged into. ADF has a special branch called the ADF Publish branch. It doesn't look like any of the other branches. It is, in fact, essentially, there's a couple of files in there for parameters and different things, but it's a big ARM template. One giant JSON file, ARM template. Whereas the other branches will contain individual JSON files per link service, per data set, per pipeline. And so I have currently my Publish from ADF Studio enabled so that I can publish manually by clicking the Publish button. And I didn't need custom comments on this demo one, but this is what the connection to a Git repo would look like. You can change if you don't want your collaboration branch to be main, that's fine. I actually do have an automated pipeline that anytime I save to my main branch, it publishes for me to make sure that the publish and the main are not out of sync, because lots of people forget to publish. So what you see in your main branch is not necessarily what is in the actual ADF service. And that is why I have that pipeline. And if I were being very formal in my development process, I would probably come in here and disable Publish from ADF Studio to make sure that I'm not overriding any of my automated processes. So let's talk about branching. I tend to work with two permanent branches, which are main and integration. Then I have developers working in short-lived feature branches. So once they get done developing a feature, we merge and that feature branch goes away. It is deleted. After unit testing their own feature, developers merge into integration. And after we do testing with all the other stuff in integration, we do a pull request to main. So main, for me, always contains the code that is ready to be deployed to the next environment. Whatever is in main is ready to go to test. So here's an example. Let's say that I have main and integration, but I've got two feature branches going. So I create a feature branch off of main to start working on branch A. I create another feature branch off of main to start working on branch B. Let's say B finishes first and they merge directly into integration. And then we decide we're going to wait for A to finish and merge into integration before we do full testing. When we feel good about it, we do a pull request into main, which is our last kind of gate to say, yes, we feel good that this code is ready to go. And we consider main to be basically like production, like this is the end. This is what's going to go eventually to production. When you publish ADF, that is when the contents of the ADF publish branch are generated and they stay in their own branch. This is what you would use if you deploy data factories via ARM template. If you are like a 1-2 person shop and you both know what you're doing, maybe the integration branch isn't necessary. I tend to like it when I'm working with people who are new to Data Factory because there's usually something they forgot to do, and I don't want to make changes to their stuff in main. So integration gives me a chance to say, hey, oh, we forgot to do this one thing that you wouldn't have noticed until you merged into some other branch. Which brings us to deployment. There are multiple ways to deploy. And again, this will depend on what your experiences and preferences and business needs are. The biggest question is, will you deploy by copying JSON files, or will you deploy via ARM template? Once you have that decided, you just decide how you're going to do it. Do you do it manually? Do you do it via PowerShell or CLI? Do you use a DevOps pipeline? So Microsoft focuses on deploying ARM templates, and you can work with that ARM template that you see in ADF publish, but it's really not my favorite way. And everybody starts out manually deploying a data factory, but you will see that my favorite way involves a DevOps pipeline. And I build mine entirely in the GUI because I'm lazy and I don't want to write a bunch of PowerShell, but you can do what I do programmatically all in PowerShell as well. But let's talk about what that ARM template looks like. So when you use an ARM template, it can be manual or automated. You can download an ARM template manually and then go put it in your test ADF to be deployed. There are global parameters in ADF that you can use to change pipeline values for different environments, but they're not usable by linked services and data sets. So it's not like you can have environment variables where it switches what database the linked service is pointed to. That's a different thing. We can do that. We just do it a little differently. So you can use the ARM template parameters for linked services to change those values for different environments. You have server A for dev, server B for test, server C for prod. Those connection strings are listed in there and you can change them. But it requires that all Data Factory artifacts be deployed each time. Your entire Data Factory, you chose to update a single pipeline out of 20, and that's all you changed. You didn't change any linked services or data sets. Doesn't matter. You're deploying the whole thing every time. And it requires that parameterized elements are exposed in the template parameters. So if you consider your connection strings to be sensitive, they will be in that ARM template. Some people care about this, others don't. It just depends. So if you are storing your ARM template somewhere and other people have access to it, and you consider it to be sensitive, that might be an issue. Realistically, you don't just deploy an ARM template. You probably have additional steps in the pipelines that deploy your data factory if you're using the ARM template. You have to make sure you've generated the current one. Stop all your triggers from deploying or from running if you're deploying when a trigger might be occurring, and then restart them after. You might need to add additional triggers or update triggers after your deployment. And you may want to actually have a separate file that has your ARM template parameters for each environment to be referenced during deployment. You also may want to decide, do you delete any objects that are not in source control so that your target environment exactly matches your source environment? Do you need to update any additional values? So it's never just an ARM template. The alternative is deploying JSON files. So this, again, could be manual or automated. The files are deployed from a source control branch. This is why earlier I said it's really important that whatever your equivalent of main is the latest trusted approved code, because this is how I deploy. I'm taking the JSON files from my main branch and deploying those. You can use ADF global parameters to change pipeline values, but again, it's limited only to pipeline values. You can use a reference file and code to update values or substitute an individual JSON file, depending on how complex your deployments need to be. But deploying JSON files, the big thing is that it allows for selective deployment. If I only changed one pipeline, I can just deploy one pipeline. The way that I prefer to do it is in a DevOps pipeline. This is not the only way, but there is a third-party extension called ADF Tools by SQL Player. It's free. It's made by another data platform MVP. And it uses the JSON files from whatever branch you designate in source control. It makes selective deployment easy. And when you need to change values from one environment to the next, you can store those values in source control as a CSV file, so it's pretty easy to read and update. And you can also choose with this extension whether or not to delete objects that are in your target but not in the source. And it lets you choose whether to stop and start triggers before and after deployment just with the click of a button. So it's a normal DevOps release pipeline here, but the tasks inside of this are my ADF tools tasks. So let's look at this pipeline. When you work with code from source control in a release pipeline, you throw the artifact in here. So I'm just saying, give me the latest code from the main branch, and it gets downloaded to the VM that's running my release pipeline. When I deployed a test, I have two activities, and both of these came from ADF tools. If you've when you publish from ADF, or if you just click the validate all button, yeah, I did that one on purpose, but this validate is what we get when we run this validate ADF files task. So we're just making sure everything works before we try to deploy. So it's just a validate, and then here's where the good stuff happens. Oh, it's not gonna make the side panel any bigger here. All right, so I'm deploying two tests. I've told it where I'm deploying to, my test ADF. This is just where the code got downloaded. This is the region of my test ADF. And then I have this environment config type. So I have UAT and prod, and there's a corresponding config CSV file for UAT and prod. I've decided to stop triggers while I'm deploying and then restart them afterwards. And if you didn't have a test data factory already, like this is the very first time you're deploying, you can have it go ahead and create that new ADF instance. Here is what I consider the best part of ADF tools. I can tell this deployment that I'm not going to deploy any integration runtimes. Maybe I share integration runtimes in dev and test, but I have a separate one for production. And so I don't want my dev test integration runtimes to be deployed to prod. Then I just say minus, meaning exclude all integration runtimes. But I can get as specific as I want. I can include or exclude certain pipelines, certain data sets, any linked services with this notation. And they have all the documentation there, but you can do wildcards, all that type of thing. So if you had a pipeline called do not publish, this minus pipeline dot name of pipeline wildcard would take care of it. So this allows me to only deploy the pieces that should go to the next environment. The rest of this we really don't change. So that lets me, I'll show you my repo here. Here's my config file. So when I go from dev to test, I'm changing which blob storage I'm connecting to. And you figure this type.property service endpoint out by looking at the JSON of your linked service. Same thing. All of these are the actual JSON behind your, let's do linked service, behind your files. So my blob storage is this one, but I can see the code. So here's my type properties endpoint. So I'm saying the value that is here, when I deploy to test, change it to something else. And that is my deployment pipeline. Real quick, I also have a release pipeline, or a regular pipeline, build pipeline that I'm using to build, and it is YAML, which I think is gross, but this one, actually, that's not the right one. this one, yeah, it is. It just failed for some reason, is the thing that actually does my build after I save to main every time. So that will be under pipelines, and the other stuff is under releases. As I said, this is not the only way to do this. This is my preferred way for its ease of use.
I have some
So,
questions real quick.
yeah.
So you mentioned having multiple data factories for each environment. So I'm assuming the way that you would set that up is for, like, your production would be to main, your staging or development would be to like an integration branch or something. Whenever you work on each one of those and like commit to it, and I'm assuming you do a pull request from your integration to main, how does that work?
So whatever's in main gets deployed to test and to eventually to prod. Everything that you develop,
Okay.
everything that you test in your, all the other branches are only in your dev ADF. There is no source control on your test and prod ADF. They're not connected at all because you're using a pipeline to copy the code over.
Gotcha. Okay, so the production isn't part, or it doesn't have the source control because you're deploying deploying everything to it from your Git branch. Okay, that makes more
Yep.
sense.
Exactly.
Thank you.
Yep. Good question. All right. Integration runtimes. There are 3 types in ADF. So the first is Azure. This is the thing that will run basically most things in the cloud that are not behind a VNet. You can have a self-hosted integration runtime that can connect to things on-prem or behind a VNet, or certain types of link services that are not allowed in Azure. And then there's a separate integration runtime that can run SSIS packages. The self-hosted, what you need to know. They are needed within any private network. So even if you have something in Azure, if it's not accessible because you've got your VNet closed, you need a self-hosted integration runtime. This is an application that sits on a Windows machine and needs to be able to access whatever the data source is. So it has to be in the same network as your data source. It is actually the thing that is doing the querying. So you probably don't want to under provision it. Give it the cores and RAM that it needs. You can share integration runtimes for your lower environments to save cost. I typically have a separate one for production. You really don't want some dev workload interfering with your production data factory. Just make sure if you share that you're sizing appropriately for concurrent workloads. So if you've got a lot of people working in one data factory, then that are using that self-hosted integration runtime, make sure it can handle the load that you're putting on it from all of the different groups running simultaneous workloads. And then make sure if there's any libraries you need that they're installed and updated regularly. The Azure integration runtime, there is one kind of auto provision for you when you create a data factory. You can use it for copying between cloud data stores and for data flows, which is the more transformation part instead of just straight control flow activities. They auto scale based on the allowed data integration units. This is a fun thing when you try to cost out, predict costs for your data factories. If you use the auto provisioned one, it's called the auto resolve integration runtime. People have complained that there are rules about what region that gets sent to. As far as you may end up with egress charges if you tried to pull data from a blob storage account in US Central and land it elsewhere. Like, there are rules and they tell you how it works and where this auto resolve integration runtime should be. But people have complained and have said they've seen costs that don't match up to what they expect. So you can actually just provision an IR so that you know it lives in US Central to avoid data egress charges. Everything should work. It hasn't happened to me, but I've seen multiple people. It's also just a thing you can't see. You can never validate it for yourself. So if you would like to remove that ambiguity, you can provision your Azure integration runtime. If you're using data flows, there's a time to live setting that you want to pay attention to. The defaults may work for you, but in the beginning, they didn't even have it set as a default. I think they do now. Just make sure it matches with what you're trying to do. And then carefully monitor your performance if you're going to use an Azure managed VNet. So ADF offers this managed VNet thing where you don't have to set up the VNet and it's supposed to keep all the traffic inside the VNet, and it works. It is often, I've seen like 3 times slower than if I used an Azure integration runtime. So it can cause extra costs because the actual pipeline runs longer. I'm trying to think who has the blog post on that. 2812 Consulting in Arizona. There are people who have talked about this online, and they went through and tested, meticulously, and were able to show that as nice as it wasn't worth it. And they ended up going back and I think setting up their own self-hosted integration runtime and not using managed VNet. It's supposed to be getting better, but just monitor performance with that. I definitely saw the slowness when I used it, but it just wasn't, for the project we were working on, it wasn't really that much of an issue. So, all right, we're coming to the last couple. Parameterize your data factory, please. When people start, they tend to not parameterize. They're very literal about what they build, and that's okay. But what happens is you end up with 100 data sets and 200 pipelines when you really could have done it in 10 data sets and 5 pipelines if you parameterize things and make them reusable. There are different types and levels of parameters. The first one is those global parameters I mentioned that are at the entire data factory level. There's also pipeline parameters, data set parameters, and linked service parameters. So global parameters might be used for connection information or a secret name that you change as you deploy. I honestly don't use them a lot. I've not found the need for them. That may be the types of projects I work on, but generally I think you'll find people do not use global parameters as much as any of the other types. Global parameters get included in your ARM templates, so that's kind of helpful. But if you're deploying from the source JSON files rather than an ARM template, that's kind of where the global parameters become less useful, and it's part of why I use them very infrequently. But parameterizing your linked services helps code reuse and reduces the number of updates required when changes are needed. What I find is my data sets are almost always parameterized. My link services are sometimes parameterized. And it really depends on the pipeline and what I'm doing, because usually the pipeline is fine because I'm referencing these parameterized data sets and link services. The biggest thing is that if you don't parameterize, your data factory quickly accumulates assets and it becomes nearly unmanageable. So instead of hard coding every possible file location in a blob storage so that each one has its own data set, I can generally just have a data set for that one link service that points to a blob storage, and then parameterize the folder or file location. So here's my general guidance. Parameterize your data sets so that you do not have an explosion of data sets. Link services, it depends on your context. And then parameterize pipelines whenever practical to make them reusable. So I'll show you my parameterized data set. And I do parameterize pipelines when I'm doing something reusable. So my source container, this is part of my pipeline. My pipeline copies from one blob storage to another blob storage in this case. And you'll see this container references the pipeline parameter. In this case, I'm copying from the same linked service, just different locations in that container. But if I open up my data set, this is my parameterized path. So I go in and I say, I've got 3 parameters: container, folder, file. It doesn't matter what you name them, you just put them in the right locations here. So that when I'm copying something and referencing this delimited text file, my pipeline can tell me what's the container, what's the folder, and what's the file. So now, if I'm copying 18 different files to or from this blob storage account, I don't need more than one data set. This is the only data set. You saw I used the same data set for my source and destination because it's parameterized, because I could tell it different locations within the blob storage account. So I told it, whenever you have a copy activity, your data set parameters will automatically appear here. So I told it, whatever container I put in my pipeline, use that. My folder for the sink or destination is called dest, and here's my destination file. Folder for the source was source, and here's the actual file that I was originally copying. These all could have been pipeline parameters, but I just chose not to for this demo. Design patterns. You kind of saw some of the design patterns that I have in place already because I use pipeline hierarchies. And there's a really good blog post by Paul Andrew about pipeline hierarchies and a bunch of good Data Factory best practices. Your design pattern should include dependencies and error handling. What do you do if something fails? Should it fail the pipeline? Should it notify someone? Should it keep going? All of that is part of your design patterns. So, oh, I know why we're back to here. These pipeline hierarchies are part of my design pattern. I'm orchestrating something, and I start by logging the beginning of my pipeline. I choose to do that in a database. You don't have to. And then I call another pipeline. That pipeline executes another pipeline and then calls a web activity and sets a status. The pipeline that gets called is that copy activity that we looked at earlier, maybe, if it's set correctly. Oh, it got unset, that's why. And so these are my kind of established hierarchies here. So the orchestrator is the top level. It probably doesn't do much other than logging and executing pipelines. My executor is doing kind of a full task of a thing. And the worker is a single purpose. The only thing in this case, this one does is copy. I have other pipelines that refresh Power BI models, and the only thing they do is refresh, and they're parameterized so that maybe I have 10 different Power BI models and I refresh them at the end of each process that refreshes their source data. I only have one pipeline that refreshes Power BI models. I just pass the location of the model I need in through the parameters. So when you're doing dependencies and error handling, ADF is kind of special. You can retry and handle transient errors that way. So if it fails the first time because there was a weird connectivity thing, you can say, I want you to retry up to X number of times. You can set timeouts. It's better now. The default for timeouts used to be 7 days. It's now 12 hours, which is much more reasonable. But if you have old pipelines, then you may need to go in and update them to the 12-hour default or something less. You don't want to be trying to hit a database for 7 days. I've seen it happen. It's silly and it costs money. log errors in the way that makes information easily usable. So you saw in my pipeline that I was logging a little bit of information to a database. You could also just send all your data to log analytics. I really like the information that ADF sends to log analytics. It makes it easy to query and find patterns. I have a blog post about querying log analytics for Data Factory where I was looking at queue times, but I needed to see it over like 100 executions, not just one. And the monitoring in ADF Studio really doesn't allow that. So if you log to somewhere else, you can then query that data later. And then you need to understand when a pipeline fails and then plan your notifications accordingly. Just because an activity failed in a pipeline doesn't necessarily mean that the pipeline itself fails. There are some exceptions. And so I have on datasavvy.me this ADF status blog post, and it tells you what combinations of failures and successes and skips will and won't cause a pipeline to fail. Sometimes you don't want it to fail. Sometimes you do want it to fail and it doesn't. So just know what the actual ADF patterns are so that you cause the right notifications to happen. And our last thing, comments
Sorry,
and
Megan.
documents. Oh, questions?
Yeah, sorry, before you go to the next topic, I guess from what you mentioned right now, you don't have a separate like orchestrator like Airflow or anything else like that that you use to orchestrate. You just use pipelines, and I guess you're not using process framework that Paul Andrew did as well. Is it, so you're just trying to manage it within your pipeline?
Yeah, so I really like Paul's framework, but
Mhm.
most of my clients don't want to deal with it. A lot of them are not that sophisticated. So when you need his framework, it is great. For like 60% of my clients, it's overkill. What I would really like to happen is that, so Paul's framework does one thing really well. He has worked around the issue of not being able to set the invoked pipeline dynamically. Like I cannot use an expression to set what pipeline I'm calling, but his involved more than just a data factory. His, I think, involves functions. I started out trying to do it with logic apps and got somewhat far, but I don't like having all these extra things when they're not needed. So, and especially because a lot of my clients don't write their own functions. And so I'm trying to go for something that's the easiest maintainable. If I need that, I absolutely use this framework. In this case, most of the stuff is pretty simple, so I don't need it.
Okay. Is there like a threshold that you have for the different clients that you use? Let's say a client in a particular resource group or container, they only need like 20 pipelines versus 200 pipelines. With, when the complexity of dependencies come into play, 200 pipelines could be more nightmares than anything else. So in that case, do you suggest orchestrators, or you still I don't know
Yeah,
you
I
have
don't
any
know
kind of
if there's
threshold?
I don't think there's a hard threshold, but I think you kind of have to judge it on your own. For some of my clients, they would rather manage 200 pipelines than manage a function. And for some of my clients, they would rather have 5 pipelines and deal with a function. And so it's really up to like your team and their skill set and their familiarity with all the technology.
Okay,
So
perfect.
it's really just it depends. But yeah, good point. I typically do not use Paul's framework unless I get somewhere that's fairly complex and I know they can handle it. I think it's wonderfully made. Just I only use it when necessary. We'll put it that way.
Got it. Yeah, thank you.
All right. Please document your code. As a consultant who comes in to fix a lot of people's stuff, it would be really helpful if somebody documented their code. The issue is you can't like open up a pipeline and comment the actual JSON code, but there are some built-in features to provide notes. So there's a pipeline description, an activity description, a link service description, integration runtime description, and then we have annotations. So there's also user properties. These are all plain text values that can be viewed and filtered in the ADF monitor, and that's why we like them for annotations. There's user properties. I just didn't click one more time. User properties, Data Factory can actually auto-generate some of these for like source and destination on a copy activity. And so they'll allow you to see values again from the ADF monitoring solution without having to actually open the pipeline. And that's why they're helpful. Annotations and user properties, really all of these should describe what your pipeline is doing and why. I generally have people put in descriptions for everything. Like that's my coding standard. If you find it necessary to use annotations and user properties, then please do, but it's not appropriate for every single thing that you build. So descriptions for everything to say what it is, why it is that way in an activity maybe. If there's something notable, you've deviated from your normal pattern, it goes in the description. And when I say description, it's this box here. This is an activity description. The pipeline description is over here. So fill in these to say what this pipeline is generally supposed to do, why you built it, something that would be helpful for the next person that inherits this pipeline. In addition to that, you could use the wiki in your DevOps project if you're using Azure DevOps, or a wiki anywhere else. If you do a really big commit, release, whatever, it can be helpful to document that. Sometimes that's just a text file with some notes. Sometimes it goes in the wiki. Wherever you typically document things, this can go there too. Again, we can now have our custom commit comments, which we saw in the configuration earlier. So that may be helpful. But documentation is, most people do not document their data factory. And it becomes very difficult when that person is not available to tell you why they did something, because as data factory evolves, there are new ways of doing things. And when people learn only the new way, they're like, why did this person do this? There was some secret thing that, you know, well, you couldn't do this back then, or really now we have this new thing, but it doesn't meet the need because it doesn't do X. That should be in your documentation somewhere. So I will wrap up. In these slides, there are a bunch of links about stuff I talked about. There's a data factory naming convention for all the individual pieces, the pipeline hierarchy stuff from Paul, the ADF tools stuff that I use for deployment, and then my activity failures and pipeline outcomes document as well. Hopefully, this gives you some things to be aware of as you're setting up your data factory that you might otherwise miss. And that's all I got.
Thank you so much. Are there any questions for Megan before we go?
I got one real quick. So the user properties is just a documentation that you name what the property is and then just get whatever that description is. It's not used for anything else.
User properties here. Let's see if I can show you one real quick.
I know where I've seen them. I just didn't know, it's just documentation.
Yeah.
Or,
So the idea behind this, like I just auto-generated the source and destination, is that I can come in here and I can start adding filters and looking for things with certain annotations or user properties and be able to see them in the monitoring. And they also go to log analytics if you send it. So it is just documentation, but it's documentation that you may want to filter by.
Right, okay, no, I get it. Thank you.
Thanks. Any other questions? I really appreciate it. Thank you for the presentation, Megan. I know even in our organization, we are doing a lot of cloud migration, cloud solutions these days more than on-prem. So a lot of what you mentioned, I feel like we have we've been doing that, which is great to know that it's already, you know, you've tried, tested it, and see what works, and could give us what is the best best solution, or, you know, the foundation. And actually a lot of these come from your blogs themselves, so I'm really thankful in person too, because I've read this before this meeting as well, to implement our solutions. So really appreciate it personally, and also on behalf of the user group, talking about this today.
Thank you. Glad it's helpful.
Thank you. Thank you so much. I'm going to stop the recording, and again,